So here we're going to show you an example of encoding a message into steganography. We're going to input a message here. Tim Park is the best is our message. And then we pick a picture that we use steganography to encode it into. We're going to use image.png, which is a picture of Tim as a young child. Here's the picture that we're going to encode it into. So it's called image.png. So image.png. You choose that picture. Now we're going to encode it with a Caesar cipher with a key of 3. And here we are encoding it. And here is the picture, steganography, and over there is the encoded message. So here we can show you how it got like steganographied into this picture. We're going to look at the original image. The furthest left-hand corner, the way we did it was the first pixel in the picture has the length of our message. So we can see an encoded picture. We can show that it's encoded by looking at the furthest left-hand pixel because that's the one that takes the most distortion. So we're looking at the furthest left-hand corner. You can see it's kind of peachish, and we look at the original image, and it's not. So we can show that it's encoded, and that's steganography. Our message has been encoded into the image.png. Here we're going to decode the image that we had just encoded. We input the image, encoded.png, we choose it. There's the message that we got from the picture, steganographied. Let's decode the message. You press in whichever cipher you used, you press in the key you used, and here's the original message, Tim Park is the best, and we've successfully decoded. Now let's say that we got an image that's encoded, and now we're trying to decode it, but we messed up a few times. We input the encoded.png, which is the one we've been using so far. Let's say Visionaires. We're going to test Visionaires freedom, and we're going to see what the decode cipher algorithm does. And that's obviously wrong. So now we're going to try Caesar. We're going to try key of 1. The original was 3. We're going to try 1. It's wrong. Now we're going to try Caesar again. This is the correct code, 3. And there it is. Tim Park is the best.
So right now, encode, the message is going to be Mom's spaghetti. Enter message, picture, image.png. So we decided to choose Caesar cipher for the first test. Now Caesar cipher, you select a key. The user selects a key, a number, a numerical value. We're going to select 3. Okay. And by the Caesar cipher, it moves it 3 spaces to the right. So A becomes D, B becomes E, and so forth. That's the transposed message right there. Now we're going to pick Visionaire. Now how Visionaire works is we select a key, which is a word, and we're going to pick freedom. Now it creates, the Visionaire cipher creates a tabula. On the top of the tabula is the key. On the left side is the message. The tabula is the x coordinate, and the message is the y, and it gets the encoded character. So there you can see the translated message. Now how the simple cipher works is that the user inputs a key that's the length of the alphabet, and they all have to be unique characters. So two letters can't be repeated. So okay. And so what it does is the first letter, which is what we selected as Q, that's A. So every time in the message that you see a letter, that's just going to be replaced by the key that you entered. And the last cipher is transpose. Now in this cipher, you create a table that has your message in it. You're prompted for the key, and you input a numerical value. So right now we're going to put 8. So the length of the key is going to be the length of the row in the table that you're going to create. And if the message is longer than the key, it's just going to go down to the next row and keep inputting characters into the table. And that's the translated message.